Okay, hello, good morning. Hi, Nana, you're the first one here. Okay, I guess the rest must have not waken up. Okay, must have not woke up yet. So whatever lah. So let's just uh continue with wherever we stopped yesterday. So okay. Anyway, where were we, huh? I think we are going to continue with our chapter 12. Okay, hello Rara, good morning. Uh, sorry, let me load my chapter 12 real quick. I haven't. Uh, hang on. This is your chapter 12. Right, so this should be in your December notes, guys. Should be in your December notes. So I will finish this chapter by today. So it will be a very concise lesson. All right, so I hope you're ready. I hope you're ready because we have a lot of things to go through today. Right, so let's look at question. Let's look at chapter 12. Okay, this is a very easy chapter. As you can see, there's only 3 pages, so we can finish this in a day. Right, so this chapter, you actually learn part of it in Form 3. You learn part of it in Form 3. So this is your nuclear energy, right? So this is your nuclear energy. Right, so where do we use nuclear energy for? Right, so nuclear energy can be used to generate electrical energy. We can change nuclear into electric, right? I think you have seen this before. This is your nuclear power plant. Many countries, they have this thing. Malaysia, they were going to build one. Okay, heard there's plan for it, but yeah, I don't know what happens, in the end. But okay, right. So you might say, sir, why use nuclear? Because nuclear, they are very energy dense. Okay, we'll talk about it later. So there are more than 30 countries in the world, they use energy, they use nuclear. Okay, America, Russia, France, Slovakia, Japan. Japan is very famous for it, right? So why use nuclear? Right, we have many ways to generate electricity. We can use hydroelectric, as you know. We can use windmill, okay, wind energy. We can use solar panel, right? But where do most of our energy come from? Most of our energy come from fossil fuel, right? Most of our energy come from fossil fuel. That means we burn petroleum, we burn natural gas, we burn coal as our energy. Okay, and just in case you don't know, fossil fuel is a very dirty source of energy. When you burn fossil fuel, it releases a lot of pollutant. It releases a lot of carbon dioxide. So this is where nuclear comes in. Nuclear, they will produce no poisonous gases. All right. Okay lah, sure lah. They produce a lot of radioactive waste. Okay, they produce another type of pollution. But in terms of global warming, nuclear is very good. All right, and don't be fooled by these things. They might say, hey sir, why got gas one? These are steam, right? These are steam to cool the power plant down. Nuclear power plant will not release any gas. You see, that's the good thing about them, right? So let's look at the benefit. It is an alternative energy that can replace or reduce petroleum and coal, right? You can replace fossil fuel, right? If one day fossil fuel were to run out, if there's no more petrol, no more coal, we can at least use nuclear, right? It's another source of energy. And next, nuclear energy is produced in greater quantity and more efficient compared to other energy sources, right? It has greater quantity, right? 1 kilo of fossil fuel, okay, sorry, 1 kilo of nuclear energy okay, where do we get energy from? We get nuclear energy from uranium-235. Okay, I'll talk about this later. Right, 1 kilo of this equals to a few thousand kilos of coal. Yes, you heard that right, thousands. Right, 1 kilo of this equivalent of you burning a few thousand kilos of coal. So how is this not how is this not better? All right, you get what I mean? So next, nuclear energy produces ionizing radiation that is used in various fields such as medicine, agriculture, and industry. Right, they can improve standard of health. I mean, you must say, sir, isn't radiation a bad point? Sometimes we use radiation for good too. We use radiation for cancer. And then nuclear energy releases very little greenhouse gas. This is the main good point. It releases very little greenhouse gas. All right, because this is our concern today. We burn too much fossil fuel, we produce too much greenhouse gases, which causes global warming. This is the problem we want to solve, right? But what is the bad point? We have radioactive waste, right? Until today, we have no idea where to throw this waste, right? The best thing we can do is to put them in a container, okay, in a concrete container. Hopefully they don't leak out, and then we bury them in the desert. That's the best thing we can do, right? Because radioactive waste that you cannot put near water because it will pollute your water source and you'll get radiation. And of course, there's the high cost of mining, all right? To get this uranium-235, you have to go and mine. Not every country has this. Guys, not every country has this. If today Malaysia were to use nuclear, we have no uranium-235. We have to buy it from America, from Japan, from Russia, from China, okay, because they have this, we don't have it. All right. So the huge amount of energy produced can cause severe harm to mankind if it is misused, right? Misuse, if you use it as weapon, right? Some people, they use nuclear for destruction. And of course, it is a non-renewable source of energy. You cannot get any more extra uranium. All right. So that's the good and the bad point. So I'll leave it up to you to process. But for me, I think nuclear is very good. Nuclear is one of the cleanest energy in the world. Yeah, sure, they have waste, but every energy have waste, right? Every energy has waste. So this is like the one of the cleanest already. Right, so let's talk about nuclear fusion and fission, guys. Please pay attention to this. Pay attention to this. In BM, this is called pembelahan nucleus. This is pelakoran nucleus, right? What does it mean? Fission is the splitting. Okay, fission is splitting. Fusion is joining. All right, or combining. Right, as you can see here, fission is when I take a big nucleus, I split it into two. Fusion is when I take two very light, okay, can you see this is like many BG here? This one only got two BG here. I take two and I take three, I combine them, I become a bigger one. This is combining. This is joining. Two small ones join to become a bigger one. This one is one big one split to become smaller ones. So there are two different concepts, but both of them produce energy. Both will produce energy, right? So let's look at fission first. Okay, this is what we are using currently. All nuclear power plants, they use this, right? I don't care whether you go to US, you go to France, you go to Japan, all their power plant, they use fission, right? So it's the splitting, as you can see. Splitting heavy nucleus into two or more nuclei, which is lighter and more stable. Okay, lighter and more stable. You see, this is very unstable. This is very unstable. So what do I do? What do I do? Can you see this neutron here? This neutron is high speed. Okay, please write down here. This neutron is high speed. So when I use a high speed, okay, this is very unstable, right? It's very unstable, but they're still holding together. They're still holding on together. But if I use a very high speed neutron, I bombard them. This will be like a bowling. When I bombard them, this thing will split. Right? This thing will split. Okay, so the nuclear fission occurs when a heavy radioactive nucleus such as uranium-235. So pay attention to this uranium-235, because this is what we use. This is the nuclear fuel, right? This is the nuclear fuel. So they will split. Okay, they will split, bombarded by a slow neutron. Okay, you can use a fast or slow neutron or whatever. So the bombardment by the neutron caused the nucleus to split into two or more, into lighter and stable nuclei. So these two, they are lighter and more stable. But this is not the main energy. This is not the main point. This process, it releases a lot of energy. Okay, a lot of energy. Can you see what happens now? Can you see what happens now? Can you see there's three more neutrons? This is where this reaction gets dangerous. You see, one neutron, I bombard this thing, it produces energy, right? Now, this will produce three more neutron, and three more neutron will hit three more uranium-235 like here. So you will produce even more energy. Okay, three energy here. Three energy here. And then can you guess what happened next? Can you guess what happened next? Every one of this will produce three more neutron, three more neutron, three more neutron. So 1 becomes 3, 3 becomes 9, 9 will become 27. Can you see this thing will threefold and threefold and threefold? This is what we call a chain reaction. Tindak balas berantai. This is a chain reaction. And if this thing goes out of control, you have so much energy, it will turn into a bomb. Right? This is how nuclear bomb works. It releases a lot of energy. In a very short time, they release a lot of energy, so much energy that it will kill you. Right? So guys, if you were to, okay, let's say now there's an atom bomb that detonates right in front of you. Okay, let's say there's an atom bomb right in front of you and it detonates. You will be vaporized. It will be so hot. There will be so much heat, you will vaporize. You know what's vaporized? You will turn into vapor. I cannot even find your dead body. Right? You know, if I use, you know what's TNT? You know what's TNT? TNT is bomb. If I use TNT and kill you, I can still find your body. It will be your dead body, you know, dead body that's, you know, you are killed by a bomb. But if you are killed by an atom bomb right in front of you, you will be vaporized. The heat is so much, there's basically nothing left, right? So that's the thing. So you see, this nuclear reaction, it's very serious, okay? It's very fast and it goes out of control, right? So you might say, sir, then we use this to generate electricity. Wouldn't it be very dangerous? Okay, I'll talk about this later. We shall control this chain reaction. You guys get what I'm trying to say here? Okay, so we don't care about this first. Okay, let's talk about the next one. Nuclear fusion, right? So fusion is by fusing, you see, as the name says, fusing or combining or joining two light nuclei. I take two very light nucleus, I join it together to become a heavier one, and this will release energy also. Okay, this will release energy also, right? So it's different concept, but they do the same thing. This is by splitting. I split, I produce energy. This is by joining. I join, I produce energy. So which is better? Which is better in terms of energy? In terms of energy, who produce more energy? Fusion will produce more energy because this happens in the sun. Okay, how does your sun become so hot? Okay, how can your sun produce so much heat? Because in the sun they do fusion. The core of the sun, they do fusion. Your sun will do fusion. All right. So you might say, sir, then why don't we do this? Why don't we do this? Why are we using this? Why don't we do this? Because this is very hard to do. Okay. Currently, we are trying to do this fusion on Earth, but our technology is still not there yet. Because you see, it's called a nuclear fusion reactor. Okay, fusion power. You see, this thing looks like a freaking crazy machine, isn't it? Right? You might say, wow, why do we need such a big machine? Guys, basically to do fusion on Earth, this happens in the sun, right? This happens in the sun, right? To do this on Earth, you are basically creating a sun on Earth. You are creating a mini sun on the Earth's surface. Okay, can you imagine how crazy this thing is? Right? I mean, maybe 100 years in the future we can make one, but until now, okay, excuse me. Okay, so until now, we cannot do that yet because this is too dangerous. This is too crazy. The amount of heat. Hey, you know how hot is the sun? The surface of the sun is 5,000 to 6,000 degrees, but the core, in the middle of the core, is 1,000,000 degrees Celsius. Okay, literally, it's 1,000,000 degrees Celsius in the middle of the sun. So we are supposed to make this 1,000,000 degrees Celsius hot. So can you imagine how crazy the temperature is? So until today, it's still, I mean, it's possible, but it's not very economical. This reactor is very expensive. So it doesn't make any sense to use this when this is expensive, right? Why don't you just use petrol? Petrol is cheaper. Yeah lah, sure lah, petrol is very bad for the environment lah, but at least it's cheaper, right? So this is why until now we are still using fission. We haven't used fusion yet. This is maybe for the future, right? So anyway, this process occurs, like I said, at a very high temperature and release more nuclear energy than fission. So in terms of energy, this will produce more energy, right? So basically, you don't need to know what is tritium and deuterium. You just need to know they are very lightweight. Two of these, they are very light. So they combine, they become heavy. Okay, they become heavy. So they become heavy, they will release energy. Okay, guys, are you guys okay? Are you guys okay? Can you guys understand? Fission is the splitting, fusion is the joining. Both will produce energy. It's just that fusion will produce more. All right, so let's look at our reactor. Okay, so if you look at the reactor, what happens here, right? Can you see what is this? Okay, pay attention to here. I want you to pay attention to this thing, which are these three. Okay, pay attention to these three. All right, so what is this, by the way? This is a nuclear reactor. This part is the nuclear reactor, right? That means, reactor, not reaction. Okay, reactor. That means this nuclear fission, this fission happens inside here. Okay, happens inside here. So what is our main guy? Like I said, the main guy for nuclear fusion is the uranium-235, right? Uranium-235 is the main guy, right? So uranium is our main guy. This is our uranium fuel rod. Okay, this is our uranium fuel rod, the red color ones, right? So it releases heat energy through nuclear fission. So this is our main guy here. This is our uranium rod. Okay, your uranium rod, it looks like this. Okay, you see? This is your uranium rod. Very dangerous. This thing is very dangerous because it releases a lot of energy. All right, so this is your uranium rod. And can you see? All right, so you might say, sir, just now you said this thing will go out of control and it will become a bomb, right? Yes, but what we are trying to do here is to control the chain reaction, right? We have to slow this thing down. Not too much, because if I slow this thing too down, then I don't get enough energy. If I don't slow this thing enough, it becomes too fast, this will become a bomb. So we have to catch that balance point. So can you see the difference? When I use a bomb, when I make a nuclear bomb, I want this to be uncontrolled. I want the chain reaction to be uncontrolled, because I'm trying to kill as many people as I want, right? You know Fukushima and Nagasaki, right? The two Japan cities that were bombed by the US. Again, you know them. So when the US, they detonated two bombs there, they want to create as much destruction as possible. So that was an uncontrolled chain reaction, right? Of course lah. If let's say you are North Korea, I want to bomb you. Why would I want controlled chain reaction? I want to kill as many people as I can, right? You see, that's the evil of nuclear bomb. So I want uncontrolled chain reaction. But when we are doing electricity, we are trying to make it controlled. Okay, we are trying to slow this chain reaction down, not too much, right? To get the amount of energy we want, right? So how do we control this? We have this thing called the boron control rod and the graphite moderator. Can you see their name? They are called control rod. They are called moderator. Do you know what's a moderator? Moderator is like a controlling guy, right? If you have been to an online forum, the person controlling what you say is the moderator. If you say something stupid, if you say something hateful, something racist, something hateful, something not nice, the moderator will ban you, right? They are there. They are like the referee of the forum. So moderator is to control things, right? And of course, the name control is to control things. So these two, their job is to slow down the chain reaction. By how? The graphite moderator, you know what is graphite? Graphite is a pencil lead. Okay, graphite is a pencil lead. So the graphite, they will slow down the neutron. Your pencil lead will absorb the neutron. Okay, you see, if I take some of the neutron away, maybe, okay, you see, 1 becomes 3, 3 becomes 9, 9 becomes 27, right? If I control like some of it, this thing will slow down. If I take away the neutron, this thing will slow down. So that's why I put the graphite moderator, right? And this graphite moderator, this is the gray color one. And can you see the control rod? This thing, they do the same thing. They control the rate of nuclear fission by absorbing neutron. Okay, your moderator is to slow down the neutron. Your boron control rod is to absorb the neutron. I take some of the neutron away. Okay, why? You might say, sir, what's the difference? The difference is, one is to slow it down, because when I slow down some of the neutron, they will not do any chemical reaction. They will not do any chain reaction. Absorb is even stronger lah. So can you see the control rods? They look like this purple. They can control this thing. If they want this reaction to be faster, they will draw out the rod. If they want this reaction to be slower, they will put in the rod. So this thing can be controlled. This thing cannot control. Moderator cannot control. They just put it at the side of the uranium. But the main point is, okay, the main point is these two, their job is to slow things down. Is to control this in reaction. If not, this thing will turn into a bomb if it is uncontrolled. We don't want a bomb, right? Why would you want a bomb as your nuclear reactor, as your electricity generator? Okay, you guys can understand, So this is our main point, right? So how does this work? How does this work? Right, so now this thing will produce a lot of heat. All right, this chain reaction will produce a lot of heat. So this heat will be used to heat water. Can you see water here? So the water will become so hot, they turn into hot gas, or they turn into steam. Okay, they turn into steam. They turn into steam, and then they will change this steam into another part. They also turn into steam. Basically, they use steam to spin this thing called a turbine. Okay, guys, all electricity generation, listen, all electricity generation, they are spinning something besides solar. You see, when you're using windmill, you are spinning the turbine. When you're using hydro, you are using water to spin the turbine. When you are using petrol, fossil fuel, you are doing the same thing. You burn fossil fuel, you heat water, water turns into steam, steam spins the turbine. Same thing, right? This thing will spin the turbine, and when you spin the turbine, you will get a generator. This is like your bicycle generator. Do you know that? The faster you cycle your bike, the brighter your headlamp becomes, because you're generating electricity. Okay, and of course, this is the cooling tower, is to cool the water down. Right, this is to cool the water down. That's all lah. But our main point is still this: all the heat comes from here. All the heat comes from here. Okay, so let me show you something. 1 kg uranium, okay, compared to coal. All right, compared to, so why use uranium? Can you see the difference? Look at this. Look at this. Oh, I was wrong. It's not a few thousand kg. 1 kg of uranium-235 corresponds to 2.7 million kg coal. Using 1 kg of uranium is like burning 2.7 million kg of coal. Can you see the crazy difference? Can you see the crazy difference? This is why we use uranium. This is why we don't use fossil fuel. Is a stupid form of energy. That's why we use nuclear, right? I don't know why is everyone not using nuclear right now. Nuclear is one of the cleanest energy to use. Okay, so anyway, so the rest of it you can read yourself. Not important. The concrete shield is to shield this reactor. You have your cooling agent, which is water. You have condenser is to cool the water down. Yada, things like that. All right, so let's look at some of the use of nuclear energy. So why use nuclear energy? Because the lack of other energy sources, like Japan, they have no petrol. Japan, they have no petrol, so they have to use nuclear. And it's a source of natural income. National income, like Slovakia. Slovakia is a very small country. Since they use nuclear, they produce more energy than they need. They produce more energy than they need. So what happens to the extra? They sell it to their neighbors. You see, extra income. And then vast country and high population density. Like you see in Japan, Japan has a lot of people. right? When you have a lot of people, you need a lot of electricity. So when you need so much electricity, what do? You use nuclear lah, right? Takkan you want to burn coal, it will be so polluting. So you use nuclear. And of course, sophisticated technology. Some countries, they can just afford it, right? Like Japan, Japan is a country known for very high technology, right? This is why you use their car, right? You see, on the road, it's either Japanese car or German cars, right? Yeah, there are some French and whatnot, right? You see, Toyota is Japan, Subaru is Japan, Honda is Japan, Mitsubishi is Japan, Suzuki is Japan. What else? All the Japanese are because they have the technology. You might say, sir, what about Barodwa? Barodwa is also Toyota, right? If you buy a Myvi, if you buy an Asia, if you buy a Beza, they use Toyota technology as well. So you see how good the Japanese are. So they have the technology to use nuclear, right? So does it mean that Malaysia, we don't have it? It's not yet. Not yet. Okay, Malaysia, we are a developing country. We are not there in terms of technology. Right? Getting there, but it's not good enough yet. Right? So maybe in the future we will use. Who knows? Right? So impact. Okay, I've said this just now before. So impact. Of course, we have the Hiroshima and Nagasaki bombing. We have to be careful with this. Somehow, some people they will use nuclear for destruction, right? Because humans, just in case you didn't realize, humans we love destroying each other. We love beating the shit out of each other. That's the fun, isn't it? Okay, you don't want to see your neighbors chatting nicely. You want to see them fight. That's the violent nature we have, right? So in order to stop this, we signed something called Nuclear Non-Proliferation Treaty. That means to stop any country from testing nuclear weapon, right? Unless there's a reason to. Okay, so nuclear test. What are some of the effects? You have tiredness, nausea, cataract, leukemia, hair loss. What is somatic? Somatic means outside. This is what you can see. Genetic means how does it affect your gene? Okay, you have deformed babies, cell mutation, and cancer. Basically, radiation. Basically, radiation. You know, radiation will make you tired, nausea, cataract, leukemia, and hair loss, right? You know, radiation will make you deform, to make you mutate and make you have cancer, right? Yeah, so you know this already. Okay, all this you can read it yourself, guys. All this you can read it yourself. Like as you can see, 70% of our energy still comes from fossil fuel, which is not a good thing because one day this thing will run out. Okay, one day this thing will run out when we finish our petroleum, when we finish our coal, when we finish our natural gas. Where else can we get energy from? Right. So this is something for us to think about. So sooner or later we have to use some kind of energy. Maybe solar, maybe wind, maybe hydro, or maybe nuclear. Okay, so okay, guys, you understand? So that's it for this chapter. You see, it's a very easy chapter. So do pay attention to these two, fusion and fission. This part could be coming out in essay. Could be coming out in essay. So pay attention here. One is the splitting, one is the joining. This is better because it produces more energy. Right? Anyway, let's go into our exercise, shall we? Let's finish our exercise. Okay, let's go to page. This is page 4. Okay, page 4. So this is the database of nuclear generation by country in 2018. As you can see, US, they use the most nuclear. Okay, US, France, China, Russia, they use a lot of nuclear. You see, many countries, they use them. Of course, it's very cheap. In the long term, it's very cheap compared to you burning coal. So which country has the most nuclear power plant? That would be your USA, of course. Okay, 3 use of nuclear energy. As I said, this is to generate electricity untuk menjanakan elektrik. Okay, any of you here writing BM? Okay, if you do, let me know. I'll write BM as well. Okay, so generate electricity. Next is for in the medical field. In medical field to treat cancer. Untuk merawat cancer. Cancer, they use radiation to treat. Okay, what else? You can use it to make bombs, nuclear weapons. I know we shouldn't write this lah, but you cannot deny that this is one of the use, right? Because I couldn't think of anything else. Electricity, medicine, treat cancer, a nuclear weapon. Okay, senjata nuclear. So, advantage and disadvantage. Okay, it produces large amount, like I said just now, large amount of energy. Okay, large amount of energy, and it's good for small countries. Okay, when you don't have a lot of land. I don't know how to put it lah. Okay, you can choose two here. Okay, I see greater quantity, like I said, to replace fossil fuel. Okay, to replace fossil fuel. Right, disadvantage, it produces radioactive waste. Right, which is not a good thing. It's very hard to handle them. They say high cost. High cost. Oh, not to mention they are prone to sabotage. Okay, prone to sabotage. If I'm a terrorist, if your country has nuclear power plant, guess where am I bombing? You get what I mean, You get what I mean. So, they are a target for unwanted individuals. Okay, so that's another concern. Right, so easy, huh? Easy, huh? So number 2. So, oh, you actually learned this in Form 3. Oh, wait, I think you learned this. Wait, is it in Form 3? Is it in Form 3? Or, oh, you'll be learning this in Form 5, I think. Oh, wait, you learned this in Chapter 8. The atoms chapter, remember? The isotope chapter. Okay, now I remember. So, name the radioactive substance used in diagram 3.1. Okay, 3.1, this is to treat cancer. What do we use to treat cancer? We use cobalt-60. This thing will produce gamma radiation. Okay, so B, state the radioactive substance in 3.2 and its function. So this is archaeology, right? So what is this we use? We use carbon-14. Guys, this is chapter 8. This is chapter 8. We use carbon-14. The function is to do carbon dating. Okay, is to do carbon dating. What is carbon dating? That means to use this thing to see the age of your fossil. Okay, see how old your fossil is. So C, give one effect of long-term exposure to radioactive radiation and to human beings, or of radioactive radiation. So we can say cancer, mutation, okay, deformities in babies. You know this lah. So D, one advantage of nuclear, it does not produce greenhouse gas. Tidak menghasilkan gas rumah hijau. So it doesn't cause greenhouse effect. So nuclear is actually very good. Right, so E, mark the correct symbol for radioactive. Okay, this is radioactive. This is explosive, I think. This is corrosive for your acid and alkaline. So this is the radioactive symbol. You will see this thing outside your X-ray room. Okay, if you go for X-ray, outside the room, you see this symbol. That means it's radioactive. Alright, moving on. Number 3, so this is a nuclear reactor. 2 use of nuclear energy, like I said, to generate electricity, for medical purposes, for weapon. Same as up there. 1 radioactive substance is used to nuclear reactor. So what does our nuclear reactor use? They use uranium-235. This is the best to use. There's nothing else. So name the country that uses most nuclear power. It will be the USA. 1 advantage, as I said, doesn't produce greenhouse gas. Produce large amount of energy. Okay, can replace fossil fuel. And write it yourself, okay? Write it yourself. It's the same answer over and over again. 1 disadvantage, it produces radioactive waste. High cost. Easy to sabotage. Again, the same answer. Okay, the same answer again. All right, so let's go to number 4. So this is your, what is this? This is fission, right? Splitting, right? Fission. So what is particle X? Particle X is your neutron. One neutron will produce 3 neutrons. 3 will produce 9. 9 will produce 27. And it goes on. So number B, what happens when particle X hits the uranium nucleus? What happens when it hits it? Okay, so uranium splits into 2 nuclei. Okay, 2 nuclei. Nuclei is nucleuses lah, okay, the plural for nucleus. So it becomes 2. So C, explain how the nuclear energy is produced from nuclear reaction above. How is energy produced? You can say neutron bombards uranium-235 and splits into 2 nuclei. This will produce nuclear energy. Right, nothing much to explain here. They just split and produce energy, lor. Right, they split, they produce energy. So I'm not sure what they want me to explain here besides this. So D, other than nuclear energy, another type of energy is also produced. Name the energy. So mostly it's heat. Okay, Haber. Like I said, we use heat energy to steam the water, to cook the water. So water becomes steam. Steam will turn the turbine. Same thing. Right? So guys, like I said, pay attention to this fission and pay attention to fusion, which is our next question. So this is your nuclear fusion. As you can see, 2 very small atoms, they combine to become a larger one, and then they produce energy. So name the type of nuclear reaction. This is nuclear fusion. Okay, in BM it's called Berlakuran nucleus. This is your fusion. And then B, explain how the energy is produced from the nuclear reaction above. So you can say 2 light nuclei fuses or combines to become 1 heavier nucleus. Alright, so this reaction also will produce nuclear energy. Very straightforward explanation. Okay, they just combine, they produce nuclear energy. Just now the one they split, they produce nuclear energy. Right, just the reverse of each other. So C, state 2 advantage of nuclear energy production through the above nuclear reaction. So what is the good point about fusion? It produces more energy than nuclear fission. And this thing, it does not produce radioactive waste. Here's the good thing about fusion. It produces no waste. You see, what is the waste? The waste is helium. Helium is a gas, right? There's nothing radioactive here. But you see, your fission, this krypton and barium, these two, they are radioactive. We have no idea where to throw these two. Because these two, they have no use. They are rubbish, right? They split into 2. These 2 lighter ones, we don't know where to throw them. But for fusion, there's no such problem. This is a gas. This is a gas. This is a gas. Everything is a gas. So, and they're not poisonous. Okay, they're not poisonous. They're not radioactive. So fusion is better. They have no waste. Okay, no nuclear radioactive waste, and they produce more energy. But they're very hard to do, right? That's the trade-off. Fusion is very hard to do. Right, so anyway, explain nuclear fusion. Okay, I think it's the same question again. What is nuclear fusion? Okay, the fusion of 2 light nuclei into 1 heavier nuclei. Hey, 1 heavier nucleus. You get what I mean, So similarities and difference between fusion and fission. Okay, so let's talk about the similarity first. What's the similarity? Okay, they both involve nucleus. Okay, they both involve nucleus. Okay, they both involve nucleus. So difference, one fusion has more energy, this has less energy. All right, one is the joining of nucleus, one is the splitting of nucleus. Okay, so many things you can say. One example of this nuclear energy in daily life. Okay, one example, nuclear energy. Where do we use nuclear energy? Like I said, electricity, weapon, medical purpose. So what are the three adverse effects of nuclear energy if not managed properly? It might cause destruction, okay, destruction of human lives. Okay, you have radioactive waste, polluting the environment. Okay, why are they giving me 2 marks though? Oh, 2 marks. They want just the 2 marks. Okay, I don't think that they need 3. Okay, so that's enough. Right, next, 2 methods in nuclear energy, fusion and fission. Again, ready yourself. This is your fission. As you can see, 1 splits into 2. So this is your nuclear fusion. Okay, please write yourself. Name particle P. P is your neutron. What is your Q? Q is your uranium-235. Because we only use this. So number 3, what are the types of energy labeled as they are being released? This is your nuclear energy. Okay, nuclear energy. So one use is to generate electricity or to make nuclear weapon. Depends on whether you want it controlled. If it is controlled, then it's for electricity. If it is uncontrolled, that is your bomb. So number 5, the particle P release will continue to bombard other radioactive nuclei that are released in this spontaneous reaction. What is this repetitive bombardment called? This thing will bombard another field, and this thing will go more and more and more and more. This is called a chain reaction. Tidak berantai, chain reaction. Okay, so C, this is your nuclear energy. So this is your fusion again. This is your fusion. Where does this process take place? Oh, sorry, this is fission. Fusion, oh yeah, fusion, sorry. So where does this happen naturally? This is in the sun. Right? So one day, if the sun has no more fusion, the sun will die. I think you learned this in Form 2, right? The sun will die one day when there's no more fuel inside them. Okay, when this thing runs out, your sun will stop burning, and then your sun will die. Right? But that's too long way lah. So next, your power station here. What is your component X? Your component X is your uranium fuel rod. Okay, uranium fuel rod or uranium rod. This is the control rod that you put in, and then this is the graphite moderator. Okay, remember, this is to slow down the neutron. This is to absorb the neutron. So B, what is the function of X? X is to carry out, what is uranium for? Uranium is to carry out nuclear fission to produce energy, menjalankan pembelahan nukleus. So C, nuclear power station requires strict control and effective safety system to ensure the proper functioning and safety of the station. 2 precaution step, 2 safety precaution. Right, this is not in note, but since they asked for it, okay, I'll tell you. So 2 safety precaution is to ensure chain reaction is controlled, okay, by using this boron rod to control the reaction. So how do you close this thing? You have to use thick concrete. So thick concrete around nuclear reactor. thick concrete here. Why thick concrete? Because concrete can block radiation. So that radiation doesn't come out, because worker will be standing here so that the radiation doesn't come out. So you need thick concrete. So the nuclear reactor leakages have severe consequences, explained. All right, because they will produce, like I said, radioactive radiation, okay, which will cause any radioactive poisoning, right? Cancer and blah blah blah. Okay, next, number 9. So this is your nuclear fission, the splitting one. And they turn into steam. Steam will turn the turbine. It will spin the generator. You get electricity. Right? So what is the X there? That would be a reactor. Turbine is already here. And the fan-looking thing is the turbine. So match the nuclear power station to its function. Generator is to produce electricity. Steam is to turn the turbine, spin the thing. Nuclear is to boil the water. Okay, so next, moving on. B. So again, you have your, wow, as you can see, the question just keeps repeating itself. So what is particle S? Particle S is your neutron. I'm not going to write, just write it yourself. This is your neutron. What is your T? That would be a uranium-235. Next, diagram below shows the town of Nagasaki after being bombed in the Second World War. Right. Here's the thing. When the US, they bomb Nagasaki, it's not because they want to kill people. It's they want to stop the factory from making more tanks and more fighter jets. Right? Because you see, if you want to stop your enemy from fighting the war, what do? You cripple their supply. Right? You stop them producing guns. You stop them producing tanks. You stop them producing fighter jets or boats or whatever. So why choose Hiroshima and Nagasaki? Okay, why these two? Because they are the production factories. Many of the production factories, they are here. So after the US bombed them, they surrender because they just couldn't produce anymore. Right? So state the negative impact of nuclear weapon. It will cause cancer, mutation, baby deformities. Okay, write it yourself. A danger towards living thing. Okay, basically ask the same thing. Okay, so in your opinion, what are the measures taken to curb the nuclear weapon? Right, so we signed something called Nuclear Non-Proliferation Treaty. All right, to stop people from. This is to stop testing, okay, or developing of your nuclear weapon. Right? Only a few big countries has nuclear weapon. You see, they don't allow us to own it, but they themselves can own it. Okay, which is the US. The US has nuclear bombs. The Russians, they have it too. All right. Anyway, next one. Nuclear tests have been done in all experiments since 1945. The atmosphere, underground, and underwater. Okay, the nuclear test ban treaty was adopted but not entered into force as there are specific states that have not ratified the treaty. Right, nuclear test towards environment, again, the same thing. Do you support nuclear test ban treaty? Up to you. You want to answer this? Up to you. Right, so you know what, guys, the rest of it, okay, there's no more question. Okay, guys, as you can see, this chapter is quite easy. All right, I hope you're okay with this. I think we have officially finished our syllabus, although in a very rushed way. Right, so this holiday, do put some time into revision, because your exam will be in January most likely. Okay, so pay attention. I mean, you can enjoy this holiday, but enjoy in moderation. Make sure you study. Right, so guys, since we finished, right, I think I'm going to stop here. So I hope you learned something new today, although it's a very simple chapter. So this will be my last time seeing you, okay, before I see you next year. Okay, so I wish you a Merry Christmas and a Happy New Year. I shall see you in 2023. Right, so enjoy your holiday. Take care. I will see you soon. Okay, so see you. Take care. Bye bye.